is you have done the lab work, you have done the measurement, and now you have to do data analysis, because this is another important thing apart from doing experiment, measurement, data. Okay, so what to do with data? So you cannot be happy or once you have data. No, you have to analyze the data. Getting the data, getting the measurement done, yeah, is one part, but it's not finished yet. You have to analyze, because based on the data analysis, you will be able to conclude, because that's the most important. Based what you have hypothesized at the beginning of your research, and this is the time you conclude whether your hypothesis is correct or whether is some other things. Okay, so if you look at the boy in this slide, I went through the data and found an 11.7% increase in discretionary spending portion. So I think he found out that his parent is spending extra, okay, of our family budget. So I see no reason not to raise allowance, my allowance, his allowance. Okay, so you can see that there are data that he obtained. I don't know why, I don't know how. Okay, and this is the data analysis. He found out there is increase in spending portion by his parents. And the conclusion is he see no reason that his allowance cannot be increased. Okay, so this is something you can see the the parents' face. Okay, this is something that they cannot deny because this is based on data. Okay, and the data has proven that they have increased spending, means that the parents have money, and the son see no reason or any excuse not to increase their allowance. Okay, so this is your steps. Actually, you get data, you analyze, and you will need to conclude. And your conclusion will be based back to your hypothesis and objective, whether you achieve the objective or you don't achieve the objective. Okay, so this is the process. You have designed the experiment. Now you do the data collection, measurement, and then data analysis. So what we do with data analysis, so this one I think I have discussed with you last week. Okay, I have also highlighted the importance of replications. Remember replications? Where is it? It's not here, but to replicate your data, make sure that you have replicates in measurements, because in data analysis, sometimes you need to do statistical study. So there is no way that you can do statistical study if you just obtain one measurement. It's impossible. Okay. What are statistical tools that you know? Can you name one, Shamim? Are you new, Shamim? Shamim, are you there?
Yes.
What kind of what statistical tool that you know?
What?
Statistical tool.
Uh,
Statis
mm, is Origin is considered?
Origin is the software, but the
Oh,
what kind of statistical test? Okay, let me rephrase.
oh,
Test that you know.
um, graph, something like graphic.
Graph, if you plot the graph. Okay, means that when you have data, you can plot graph, you can plot bar chart, you can plot pie chart, for example. Okay, okay, thank you, Shamim. It's okay. All right. So let somebody else enlighten us. Any statistical test that you know for and for what purpose? Anyone? Just tell us. I'm sure that you have learned statistics during your undergraduate. Anyone has heard of Q test? Well, this is why physical class is much better. But I understand your sometimes some of you prefer online classes, so please be interactive. So, what kind of what statistical tests that you have experience using? Anyone? I'm sure you have. Izni? Muhammad Izni?
Yes, bro.
Yes. What statistical tests have you done
Mm,
before? Mm.
mm. Something like using the graph, right? Like one way ANOVA or something like that.
ANOVA is a statistical test. Thank you. Okay.
Yeah.
So, right. Have you heard everybody about the Q test, the T test, the F test? Okay. And then somebody said about there are one tail ANOVA, two tail ANOVA, two tail T test, and there is chi-square test. Okay. So those are tools that you need to use for data analysis. So in this subject, it is 5901 research methodology. I don't teach detail for this statistical because this you have to take a subject under statistic. Okay. But it is very important for you to know statistic for analytical chemistry. It's not because you're not doing analytical chemistry, but you are to analyze your data. Okay. The minimum that you need to know, at least the student T test, the Q test, where you need to evaluate your data, whether you need to remove data, whether you need to retain data, whether you have sometimes you have outliers. So how do you decide to remove it or to keep it? Okay, it's not just by doing analysis in your head, you have to do the statistical analysis. Okay, and definitely when you plot graph, you have to consider uh, the error. Okay, so there are random and systematic error. So systematic error comes from you as the operator, but then you improve along the way your skills, whatever that you are doing in the lab, your skills increase. Yeah, you are getting more uh, accurate in your protocol, in your uh, whatever that you're doing in the lab. There are also possibility that there is error from the instrument that you use, from the glassware that you use. Okay, so those are what we call a systematic error that you actually can avoid. You make sure that the instrument that you use is verified, is correct. Okay, if it is the glassware, the not auto, the micropipette is okay, it's working, it's supposed to be giving you the right volume. Okay, those are things that you have to check before you do any analysis. So that is why we need to do, there's another one error called random error, which unavoidable most of the time. Why? Because it is sometimes due to temperature fluctuation, moisture, or it's random. That's why it is called random. And how to treat this? How to treat this random, especially random error, is by using statistical mean. Okay. So when you have data, right, you have to evaluate the data. First is by Q test. There's a lot of name for the Q test, but it is for evaluating, especially you have outliers, suspicious data. It's a bit, that is why it calls outliers. It's a bit weird from the other data. And then you have to look at the precision, which is the F test. Precision is how close the data to each other. I think I have, okay. Precision, how close the data to each other. This is precise, but it's not accurate to the actual data. This is a blunder. It's not it's not precise at all, and it is not accurate to the expected value. Okay, so this comes from random error, and you have to solve it. If not, then the data will not be that valid. Yeah. So remember that you're doing something wonderful in the lab. So make sure that it is real, is validated. Right. So right. Okay. So replication, definitely, because in order for you to at least do standard deviation, as standard deviation, you can do like error bar, yeah, a student t-test. It requires you to have replication. Okay, you need to replicate the same measurement, the same set of data, the same set of sample, the same set of sample, and then to obtain a set of data. Okay, so you have to replicate. Please do this. Please replicate. Don't just do the measurement once, or don't just do the preparation once. Yeah, right. So I'm not going to teach you how to do t-test, how to do f-test, because those are something that you have done during your undergraduate, and this is not an exam. You can just open anything that you wish to open. You can do the the statistical analysis using Origin just now. You can do using Excel. It can be calculated very easily. Okay. So I hope that also you need to revise on how to construct a proper calibration plot, to look at the regression, the correlation. Okay, those will not be taught in this subject, because this is something that you can do by yourself. Yeah, you can just open up any statistical book or just analytical chemistry book and look at how to calculate t-test, f-test, q-test. That is minimum. ANOVA usually we use if you have a lot of data. And those who are working with biological sample, okay, where they have to obtain a lot of data, they have to use ANOVA because it's multiple factors. Okay, but for us analytical chemists, data from chemistry experiment is not that many. The factors are not that many. So probably you can just use simple t-test, yeah, just to check on the accuracy, and f-test is on the precision. But usually t-test is good enough. Once you have the t-test, is good. You start with q-test to evaluate the data, and then t-test. Okay, so this should be at your fingertips: standard deviation, t-test, error bar, okay, and plotting calibration plot. Make sure that you know the term regression, correlation. Okay, is your correlation good between 0 to 0.9? Okay, so you have to know how to evaluate your data. Right? Okay. Right. So I have talked about this. These are your measurements. Yeah, it can be blunders. It can be here precise, but it's not accurate. So the best, you have to get it precise, which is the data should be close to each other. And it should be close to the predicted value. Okay. Okay, so I think I have talked about the precision and accuracy. So once you have done the analysis, this is where you start to plot the graph. Okay, you plot the graph together with the standard deviation. You put the data in table plus the standard deviation plus minus, or you put it in a graph form plus the error bar. Okay, so what happens if you have this kind of error bar? Okay, so you can see this guy, this is the error bar. So the error bar comes from standard deviation. So this is the data that you plot. Okay. Now you can see one of them, one of the data set has a very big error bar. So you can see that somebody talk about, sorry, we just can't trust you. Why? Because the error bar is too high. Okay. So usually acceptable limit is 5%. Okay. But the lower you go is much better. Right. So if you have this kind of results, then you should first, you are the one who's supposed to question your data first. Yeah. You don't wait for others to look at your presentation and comment on your data. You, as an ethical scientist, you comment on your data. You look at your data, and then you should feel responsible to do something about that. Yeah. So as I said, it's not just for you to do measurement and you get data. That's it. No, you have to analyze, and then you ask yourself, why do I get this kind of high error? Is there something that I have done in the lab or something that I've done during the process that contribute to this high error? Okay, so as a scientist, we should have this critical investigative mind, okay, asking about your own data. Okay, why do I have this? Why do I have this one? Okay, there's possibly something happened. Probably that I have done something wrong. Okay, so you go back to your lab book, look at what you have done. That's why your logbook, whatever that you call it, is very important because you need to trace back what you have done in the lab. Okay, and you don't want to repeat the blunders. You don't want to repeat the error because you already know that this is what you have done and giving you this. And so based on the logbook or lab book, okay, you don't want to repeat the same set, right? So now you need to probably change something, right? So in order to us to give meaning to data, because once we have data, we need to interpret, we need to analyze, and we need to interpret. But if your data gives out something like this, then you cannot give meaning to it because obviously it is not acceptable. Okay. So you can see after analyzing all your data, I think we can safely say that none of it is useful. So we don't want to end like this. We do not want to end like this. You can, um, that's why designing an experiment is difficult because we have to consider all things, the possibility of error, the possibility of wrong method being used, the possibility of the machines are not good enough for you. So we have to we have to really plan plus the limitation that we have. Okay. So be careful. You don't want this to happen, that your data does not make sense. I am, in Viva session for me, it's very important. This, but you don't want to, um, at the stage of Viva is when you set at the end you uh, oh, what is the word? You finally think about it, and the assessor or the reader or the one that examine your viva point out the data does not make sense. So you don't want to go until that stage. Okay, it is during the data collection, data analysis. It's not during the viva. Is when you should be evaluating your own data, and your supervisor should be also helping you on finalizing the data, whether it's good to go, whether it's not something useful, or is there's something wrong and you need to repeat. That's why you need to talk to your supervisor. Okay, they do have experience, right? So making sense to your data. Yeah, I think you know, it's because you mentioned you can plot graph, you can plot bar chart, you can plot, put it in table form, okay? And then you can discuss the data. You can discuss, it's not discussion, the discussion is not about, okay, it's increasing, decreasing. No, giving meaning to data is beyond that. Yeah. Okay. If it is increase, what does it mean? If it is decrease, what does it mean? Okay. It's not about telling the graph is increasing. The graph is decreasing. The data is decreasing. You have to go beyond that because you have done the literature and you understood better on the fundamental, on the theoretical parts, and now you start to apply your knowledge or whatever that you have read during your literature to the data that you obtain. Okay, I hope that I'm making sense. All right. So we don't want this. I can be outspoken during Viva. That's why people don't invite me anymore. If the data doesn't make sense, then I say the data doesn't make sense. Okay. In science, you have to be ethical. Okay. In data interpretation, the bias, yeah, because I understand, of course, we want it to be what we want it to be, okay, but the results doesn't seems to fit what we want it to be, okay. But sometimes we yeah, there is a tendency that you try to tweak something to get to the conclusion that you want. So that this is something very dangerous. Okay, so avoid doing that. You might be having false positive, false negative results. That's why ethic is there. Do not be biased. If your result is like that, talk to your supervisor. Think about it. There's a lot of thinking that you have to do. There's a lot of reading that you have to do. It's not as easy as washing dishes. It's not as easy as cooking, but you learn during the data analysis. Definitely errors will be there. So you have to manage the errors. Remember one thing that I always remind my students that whenever that you have negative results, don't throw it away. Do not throw it away. Keep it there. Keep it there. Okay. Do not hide them. Okay. Talk to your supervisor about those negative results, but don't throw it away. Don't throw the. If you can keep the sample, it's also very good, and the data also keep it. Make sure that you keep it. Okay, because one day might be useful. Yeah? You never know because probably you haven't read about that part. You just read about something. Uh, you haven't reached up to the negative, probably negative results. So just keep it there until one day you read and you probably decide this is something new that you have gotten. So probably is good for your observation is good for reporting. Right? So please do that. These are just tips, but you have to do it by yourself. You have to learn the statistical by yourself. You have to learn to plot the graph, to do a calibration plot if you need to. Those are very important skills. Okay, which is have to learn by yourself. Okay, but I'm sure that you're good because you're very young. Everybody is very energetic, and I think you can just learn in a very short time. If you don't know about the statistical analysis, you can do it by yourself. Okay, this is something that it's not graph, it's not table, it's not data, but is a results of morphological study. Morphological study, there are certain ways for you to analyze and to report. It depends on what are you looking at. Morphological means surface or how it looks like. Okay, what are you looking at? Okay, so in morphological analysis, unless you have EDEX together, if you have EDEX, then you can mention, okay, you have silicon, you have gold, and you can talk about the percentage. It is not absolute, it's percentage based. What does it mean? That it can only show you the percentage. So it might be low if you have other things in greater amount. For example, here you have a lot of carbon. So when you have a lot of carbon, those who exist there in very low, then you have probably low percentage. So it's not absolute value. Now, if you don't have EDEX, for example, you don't have this part. You only have the morphological study. You cannot say, oh, there is silicon nanowire, there is gold nanoparticle, no, because you cannot see them. You can just only comment on the morphological. Like here, you have some porosity, and then you observe some probably this I don't know, rod shape, or you can just comment on the morphology. So that's why you need to do EDEX if you really want to comment on the elemental part. Okay. I usually read thesis and they mention about, oh, there's a shining, probably presenting gold nanoparticle. No, it's bullshit. Yeah, you cannot, you cannot even say there is something there. You can only comment on morphological, how it looks, porosity, the shape. Yeah. And you have aggregates. That's it. That you can, once you have EDEX, then you can comment on the elements in this whatever compounds that you are preparing. Okay. So please get that. I mean, you can only comment based on the suitable uh, characterization. If it is surface, then you talk about surface morphology. If it is elemental analysis, then you talk about elemental analysis. So what is the objective that you're doing this? So in this case, the objective is to confirm the modification, mean embedment of embed of silicon nanowires and gold nanoparticles. And from the elemental analysis, it is there, it's proven there. So the conclusion is it is there, but that, and you can also comment on a percentage. Is high or low, and then you can start comment on the surface morphology. It gives out what it seems to be aggregated. Well, if you need to talk about the porosity, talk about the porosity. Okay, so that depends on what you wish to have. If you want higher porosity, then you talk about higher porosity. Now, if we have like a graph, okay, so you can see that here, presenting the graph can be also difficult. Yeah, presenting the graph can also be difficult. Make sure that what you want to conclude. So in this case, the students, former students, wish to relate the resistance with the number of nanowires. Okay, so she wished to talk about the correlation between resistance and the number of nanowires. Okay, so now you can see that 1 single nanowire, 10 single nanowires, and 20 single nanowires. And this is the resistance. Okay, so you can see that there is no error bar. Okay, right. There is a difficulty because these nanowires are very expensive to produce. This is what we call as photolithography method. Is called top down. Top down means that you have to use a special machine to get the nanowires. So some are forgivable. Some are forgivable. But yeah, and then we look at the results also. It seems that the trend is there. Yeah, it's not like you have high, low, whatever. It's very haywire. No, the trend is there. So there are some that you cannot repeat, okay, because the cost is very, very high. So there's some forgivable. Okay. So working with nanowires because it requires special machines and it's very expensive. So at least you get to know the results are very good. It looks good and it sort of compliance to the theoretical value, theoretical aspect, the fundamental theoretical. Yeah. So when it is compliance, then you are safe. Okay. So that will be data analysis and interpretation. So I think we take a 5 to 7 minutes break, and then we start with the communication, and then we end with an example. I'll be showing you an example of slide so that we can see the example of experimental design, objective, and what to put on your slides during your proposal, progress, and final. Okay, so I'll see you around 3 plus, 3-ish. Okay. All right. Before that, before we discuss a bit on the presentation and looking at example, I just want to tell you that you don't have to worry about your attendance. Okay, I will help you. Okay. My major concern is about whether you you understand the discussion or not. And I wish that all this experience-based knowledge can help you with your research. Okay, so that's my most concern and my main objective. Okay, so don't worry about about your attendance. Okay, because that is not an issue. You are at different level, right? Okay. As a researcher or doing research, there is something that you can't avoid, which is you have to present your data. So you have proposal presentation. You also have a progress presentation for PhD, and you also final presentation. I think for master you don't have progress, you only have proposal and probably final. I don't know the one that is compulsory, and you might have to present to your group meeting. Okay, so there are not to say that this is something that you have to follow, but it's just a tips on the presentation wise. What I'm going to show you is not actually academic presentation, but you can use the same style for academic presentation. I will be highlighting in the actual, in the example, slide example of how you can adapt this style in academic presentation. Yeah. Okay. All right. In science, especially in science, yeah, um, the most important is how you can articulate the message that you want to relay to the audience. Articulating does not mean about your slides only, but is how you present it. The words that you choose, the sentences, the body language, all inclusive in articulation, in articulating the message, the data or whatever that you wish to relay to the audience. So we need to consider everything. Okay, right. Always remember this. Okay, the audience or whoever that is listening to your presentation, they are human being. Okay, so as human, they have this. Where does it go? As human, okay, they have limited time span uh, in terms of interest, and they also perceive, okay, uh, differently. The audience perceive differently from what you perceive. You might think that why don't they understand my presentation? Because you perceive differently. The audience will perceive differently. So when you are to present something, okay, this is not just for a proposal, just it can be for your future presentation. You have to study who's going to be your audience. If it is a common people, if it is a scientist or scientists of different field of study, you have to tailor your presentation accordingly. So let's say if you are presenting to a very uh, highly professional, highly skilled in that particular area, then you don't have to talk about the introduction a lot because they understood already what you want to say about nanomaterial whatsoever. Okay, but if you're talking to common people, then you tell a different story. Okay, so you have to know your audience, right? You have to know your audience before you can articulate whatever messages that you want to give to the audience. All right. Means of communication means that it can be online, can be physical. If it is physical, make sure that you know how to handle yourself, how to position yourself. You do not block your slide. Make sure that you at least know how to handle technical stuff. Okay, but you since you are young, you're better than everybody else. Okay, so make sure that you know how to handle the slides, how to position yourself, how to look at the audience. Yeah, right. So please remember they are human being. Okay, so articulation inclusive of you have to practice and using a proper language. It's not nice, a proper language. Okay, a proper sentences, a proper term. Okay, so this one requires you to practice. So do practice. Practice makes perfect. Okay, so and then these are the team. Okay, when you present to, let's say, you want to ask for money for funding. Okay, that this is different story. Then you have to present who are in your team. So in your case, you also need to know why you need co-supervisor. Okay, it's not just they are not there for the sake of their name, no, but it is because your supervisor has only a certain limited expertise in his or her field of study. But in order to widen the horizon of your research, sometimes we have to add some value and we need to invite someone else as your co-supervisor. So having a good team, enough skills or experts in your team is it should be a blessing. Yeah. The rest are, yeah, if you are presenting for grants, then you have to really read the grant guideline. If you are presenting, defending for a fellowship, then you have to really read the guideline for the fellowship. Do read the guideline. Right. So these are tools that I have used and I have been trained to, yeah, in order to, as I mentioned, I have pitched to companies, I have pitched to industry, and also governments to obtain money. Yeah, so you have to study their needs, okay? Because certain fund provider they have different needs, okay? And for example, for your proposal, it's not really an issue to understand the needs of the audience, but you to present your idea because that's what you have agreed with your supervisor, right? So this is something related to, you can relate needs to problem statement. Okay, it's not the needs of the audience, but it's the need that you have agreed upon with your supervisor. So you tell about the problem first, what you want to solve. Okay, right. So I'm just putting in some example. If you're presenting to DARPA, okay, DARPA is a Department of Defense, US. Okay, right. So this is problem statement. So talk about problem statement. How do you talk about problem statement? Okay, and then you talk about the solution. This is your solution. Yeah? If you are to sell something, then you have to convince the audience. So if you are to convince the examiner, like me, you have to be firm about your solution. Okay, firm here is scientific base. Yeah, it's not firm because you believe it. No, because you have very sound scientific understanding and you understand the theory, how it works. And based on the theory, you proposed. It's not about this is the best, but there is no explanation on the scientific. Where did you get where did you get the idea that it's going to work? No, you have to present that. If you are presenting for academic proposal, then you have to present that. Yeah, so this is problem. This is the solution. If you are selling things, then talk about the benefits. And this is the method. Okay, so how are you going to do that? You have the problem, you have the solution, and you really understand about the solution. You really confident that it's going to work, and you explain this is the science behind. Okay, fine. Now, how are you going to do that? What's the method? Okay, so this is method. So if you are, again, if you're selling something, uh, some cosmetic, right, for example, you're talking about removal of pigmentation. For ladies like me, uh, we have this pigmentation issue when it comes to 50 years old. Then for me as a scientist, I will ask, how does it work? What are you using? How does it work to remove the pigmentation? How does it work to what do you call? Not remove, is to avoid pigmentation, for example. So you must understand the science, and this is what you're gonna do. You are going to use like certain acids, okay? Hyaluronic acid, kojic acid, and you want to put it in patch, so it's easier for us to use, okay? Um, at night, then uh, you get a glowing skin, probably. Okay, so the method section has to be presented as well. And this is about uh, giving the idea to the audience about how novelty. If it is academic proposal, it's about the novelty. It's about, if it is about selling your product, then you have to be better compared to your competitors. What's good? What's your features? What's your special features? So you have to tell them, okay? Same like academic proposal, you have to tell the novelty. What's unique about your research? Okay, this is not inclusive of NEBC. NEBC is a need, benefit is B, approach A, and C is the competition. So iteration is about practicing. Okay, in order to get a very, in order to be able to speak fluently, uh, in order to articulate well, you have to do practice. You have to practice. You have to iterate, improving the skills of presentation until, yeah, it's not, it's never perfect. It's not going to be perfect, but at least you are there. I mean, you will be able to articulate your idea. Now, this one, I think you just think about it. Okay, you have probably joined certain conferences, or you have joined people presenting. Then you know which one is good, which one is not so good, and you want to try to avoid that. Yeah, right. So this is the presentation phase. Usually you are given, for example, 15 minutes, that's good enough. But this one is the normal one, is 8 minutes. Yeah. And I haven't talked about hook. This is something extra. If it is academic presentation that you have to do, academic proposal, I'm the evaluator, then I have to listen to you because I have to evaluate. So there's no need for hook or whatsoever, because definitely I have to listen to you. Okay. But if you are presenting your idea, okay, and you want to obtain something from the presentation, for example, money especially, you want to obtain funding, hook is very important. So what is a hook? Which is 24 seconds only, okay? You can do it, where is it? Because the name is there, is hook. I don't have it here. So the name is there, is hook. You need to hook the audience. You need to engage them. So there are many ways for you to do it. It's not just like asking questions. It's quite common. Okay, asking questions. No, you can tell stories. You can show pictures. because you have the opportunity to have slides. You can show statistic, you can show pictures. So you don't have to straight away show your title or whatever. That you can start with engaging them. Okay, if you're good in jokes, then please. But if you're not good in making jokes, don't do that. It's up to you. So whatever it is, you have to hook your listeners first. There are many ways to do it. It's up to you. Okay. And then you start to talk about the problem just now. Okay, you can see that problem also have a lot allocation. 1 minute means that it is very important. And how do you do it? Definitely, this is the biggest 4 minutes. Yeah, because you want to tell people this is how you want to do it. You want their money, and this is what you want to do it. This is what you want to how you are going to use their money. Okay, so this is very important, and this is very um, important in understanding who's your audience, because some those grant providers, they are not scientists. They just listen to you, but they don't really want to understand the idea. But the approach, the methodology depends on, I mean, the money depends on them. So you have to really know how to simplify the process, but it makes sense. The science is there, it makes sense, but just not bore the non-science people, because some of them are not scientists. Okay, but they have the power. Yeah. So benefits, of course, don't overclaim. Okay, don't say, oh, this is the best. My product is the best. My product is going to be the best. No, don't overclaim. Don't what do you call, what's it? Don't lie. Okay, you know the limitations. Just talk about the actual uh, prospect of your outputs. Yeah. So competition, right? So again, don't lie, don't overclaim that your whatever that you have is the best compared to the others, right? And rounding off, okay, depends on the situation. If you need to conclude, then please conclude. So I think by you should have around 8 minutes. Yeah, this is the practice. Okay, okay, let's look at one last slide. I just want to share with you. Mm, all right. Because soon I believe that you're going to have to present your proposal, right? So this is just a tips, because this is Viva slide, but in Viva you have to talk about all, even the literature, problem statement, um, methodology. You cannot skip. It's not just about the results. You have to talk about all. Okay, so whenever that you, so I start with proposal. Let's say you are presenting proposal, right? So when you are presenting proposal, uh, the most important is how you present. You highlight your title, okay? Because you wish to highlight the novelty, all right? So because the novelty will be related to your problem statement, okay? So when you're presenting your title, you highlight which is the keywords. So probably here for us is we are talking the key about dual bioreceptors. So people who listen to your presentation now have the keywords that I want to search for in your later slides. So dual receptors, probably APTA sensor, because the rest are just general. So APTA sensors, dual bioreceptors. Okay, those are keywords from the title. So remember about that. When presenting, highlight the keywords. Okay. So now you're talking about introduction. Okay. While talking about the introduction, you highlight the problem statement. Okay, why do you want to why do you want to continue working in this? Okay, in this case, we're talking about TB. Okay, so what is the current technique being used? Okay, right. So this one depends on your title, depends on your research. And you have your proposed solution. Okay, so during what this we discussed about graphical abstract. So this is graphical abstract. Okay, the whole idea of what you want to do. This is the whole idea of your solution. Okay, so for my solution, I want to use, okay, this technique, which is electrochemical technique. And I want to have dual bioreceptors. Remember about the key in the title? We're talking about dual bioreceptors. So I have dual bioreceptors. And I'm using aptamer. Okay, so another keyword is here. And now for graphical abstract, you can also put some text. Okay, so this will give some people, okay, this is your idea. And you highlight probably there's why do you want to have dual bioreceptors, for example? That depends on your research. Okay, and then you have to present the literature review for proposal. That is very important. Okay, tell a story. Okay, in literature review, you tell a story. You don't read the slide, you tell a story. Okay, what you want to present to us? You want to present on the preparation, which method of preparation is the best? Now you make a comparison between all those that you have read, and you highlight the one that you think interesting, and this is the one that you want to use. Okay, so literature, please tell a story, not read the literature in front of the examiner. Now, once you have done that, you know already about the problem statement and you know your approach. Yeah, remember the proposed solution just now? So the proposed solution is using electrochemical in this case. So you want to modify the electrode, okay, because you're using electrochemical. So you prepare a compound, okay. So your first objective is to prepare the compound. Okay. Usually you don't have to spell out to synthesize, optimize, and characterize, because when you mention about preparation, it includes everything. You have to optimize, you have to do the formulation study, and you have to characterize. You don't have to spell out in your objective. Okay. And then the second one is about the electrode. Okay. You want to do the dual bioreceptors. So you put whatever that you need here. Okay, and then the electrochemical part and the analytical performance. So you don't have to be very specific. You want to do FTIR, XRD, whatever. You don't have to put it in the objective. And now comes the experimental design, which is what we discussed last 2 weeks. Yeah. This one is very important because it gives you an idea where to start and where to end. Okay. So the first, because these students is using aptamer as the biomarker. I'm not going to talk about what is bioreceptor biomarker. So he has to characterize that one first. And then since he is using this compound called diazonium salt, then he has to characterize this one first. And we have to decide what kind of characterization requires to make sure the formulation is correct. And this one, the method is Ilona. Why there is another method, but it is expensive and it is out of our. It's difficult for us to get there to access because of the the problem with human. So we finally decided to use this method, Ilona. So this is after a discussion with me. Okay, the students present. Okay, we tried to get analysis to outsource analysis, but we have problems with the administration. Then we finally decide to use this. And then comes the electrochemical. What do you want to do? What kind of characterization? And then you know what to expect. Probably you need 2 years or 1 year to do this. And then for us who are doing biosciences, we have to do real sample analysis. It's not enough synthetic sample, especially for PhD. And if you intend to publish in good journals, you need to have real sample analysis. So for us, because it's tuberculosis, it's not easy. It is not available just in any hospital. Even to get to the hospital is difficult. So we have to think about how to get the samples. And now, yeah, finally. So the time span depends on also difficulty of the accessibility. For those of you who work with material, I think you are lucky because you can do the analysis in the lab. You don't have to do the application. But for us who do application work, we have to apply. If not, then it's difficult to publish. Okay, so you can see that this is where you are for proposal. You need to be able to talk about until here. Okay. Now, you can see that this student also relate the steps with the objective. So now it is clear where you actually achieve objective 1, objective 2, 3, and 4. Okay, since there are only 4 objectives, so now you know where you can cover everything. All right. So you can see that from the experimental design, you start with aptamer binding and also compound material characterization. So you can see that the first slide. So let's say now you are presenting progress. Let's say now the first stage is proposal. Now let's say you are presenting progress. Let's say. So you have to tell the examiners the objective and where you are. So let's say you're talking about this is your progress and you only have the first 2 done. So you have to tell, because if I'm the examiner, I will not, I'm not your supervisor. I do not know where you are at, and I do not know what you're going to have to do until you finish. So you have to tell the examiners that I am at this stage, I am at this stage, and this has not been done yet. Okay? So you have to identify based on the objective, and this is the results that I have obtained for the first and second objective. Then I will give you good marks. Because if you don't tell me that I don't know, and you are at certain semesters, I don't know what is your progress. Okay, you have to highlight us on the objective. Okay, so the first objective is here. Okay, so this is the results for the first objective. So it is proven that the binding is there. It is good. Okay, if it is not good, then you cannot use the aptamer, for example. Right. So the second objective is the preparation of diazonium salt. This is also the first objective, sorry. It's about the material. So this is what you have prepared, and this is the evidence that you have, proof that you have prepared it well. Okay. And for the surface modification, there is also some additional here. Okay, the characterization, you have FTIR, XPS, for example, contact angle. Yeah. And then furthermore is on the electrochemical, because that depends on what technique you are using. Okay. So be very clear in presentation, especially for those who are presenting progress. You need to highlight which objective you are working right now, which one you have completed, and what's the results. This your this objective has been obtained or has been answered, or there is some issues with the objective. Okay, because things happen. Okay, so if you have a problem in answering the objective, you have to talk back to your supervisor, discuss. I don't think so that we can achieve this objective. Can we change the material? Can we change the objective? That's supposed to be doable with your supervisor because you know him or her better. Okay, you don't want to fail because you have limited time. So now you foresee that you're going to have issues with the second, for example, second objective. So you want to change. That is something that you can do. All right, I think I have um, give you some tips. Okay, so this is your for your proposal, and also this is for your progress presentation, and the same thing goes for your final presentation. Is more or less answering the objective and giving evidence based on the results. Yeah. Now, let me show you if there is you can see bar charts here. Okay, so the error bar charts, sorry, the error bar. Okay, you can see the error bar. So this is very important in presenting data, right? Some more error bars. I would like to, okay. So calibration plots, correlation, R squared. Okay, those are very important. So you're working with limit of detection. So please get to know how to calculate. All right. Other than that, if you're good in some software, yeah,